Hey everyone, I'm Dr. Gray. I'm going to be going over your exam. Um, this is exam 2.2 and 3.1 for engineering chemistry. The first question in your exam is balancing a chemical reaction. CO2 plus H2O yields C7H6O2 plus O2. What we were trying to balance with this is we're trying to balance carbon, hydrogen, and oxygen. And I'm going to set up a little table like this where I first count the numbers of carbon, hydrogens, and oxygens on my reactant side and my product side. Reactants over here, products over here. And I'm just going to basically keep track of them. So if I look on my left-hand side of my reactants, I've got a total of 1 carbon, and I've got 7 carbons on my product side. Hydrogens, I've got 2. Oxygens, I've got 3. On my product side, I've got 6 hydrogens and 4 oxygens. Now, one of the things that I notice about this is I immediately encounter a problem in that I have even numbers of hydrogens, and I have odd numbers of carbons and oxygens. But my first my first action is going to be to put a coefficient of 7 in front of CO2. And whenever I do that, I'm going to add another line because I'm increasing my coefficient in front of CO2. Now, rather than it being a 1 there, I've got 7 carbons on my reactant side. So I no longer have 1, I've got 7 carbons. Now, for my oxygens, I'm going to go from 3 to 15. Now, this presents a little bit of a problem because even whenever I balance one thing, so the 7s for carbons on my reactants and product side, it's an odd number, but it's not really a problem because they're equal to one another. But my oxygens, I have an odd number of oxygens on my reactant side and an even number on my product side. So now what I need to do is to kind of account for that and accommodate for that. And the way that I'm going to do it is by continuing on with my reactants. And what I see with my reactants is I've got a total of 2 hydrogens on my reactant side. I've got 6 on my product side. So for that, I'm going to multiply or put a 3 coefficient in front of H2O. So that's going to cause my hydrogen number to jump up to 6. I still have 7 carbons. My oxygens are also going to go up because I'm going from 1 in H2O to now I have 3 of those. So I'm going to add 2 more. So that gets me to 17. So I still have this problem. I have an uneven number or an unequal number of oxygens on my reactants and my product side. And it's not just that they're unequal, that it's that one is even and one is odd. So what I'm going to do to account for that is I'm going to take that 17 and I'm going to multiply it by 2 because I can take an odd number and make it an even number whenever I do that. But if I do it to that, I've got to do it to everything else. And the way that I'm going to do that is I'm going to take this 7 coefficient in front of CO2 and I'm going to make it 14. The 3 coefficient in front of H2O becomes 6. So now I've got 14, or oopsies. Yeah, 14 carbons. I don't know what I just disappeared for a second. I've got 12 hydrogens. I've got 2834 oxygens. Okay, so now that I do that, I'm going to switch over to my product side. And the first thing I'm going to do is I'm going to balance my carbons. And I'm going to balance my carbons by putting a 2 coefficient in front of that molecule C7H6O2. So that means I'm going to have 14 carbons. Now I've got 12 hydrogens here. So 12 hydrogens. Now I've got 4 oxygens plus, well, 2 oxygens. So I'm at 6 oxygens. Okay. So what I can now do is say, well, I've got to get all the way up to 34. So how can I do that? Well, if I've got 4 oxygens, or sorry, not, yeah, that's right. basically I'm asking what coefficient can I put here to get me to 34? So essentially what I'm asking is, how can I get 4 plus blank times 2 equals 34? Because this blank that I put a little line under is this number that's my coefficient. So way I can do this is subtract 4, subtract 4. So now I'm looking at 2 times, I'll just put an x here, equals 30. So 2 times x, divide each side by 2, x equals 15. So I've got 15 O2, so that's 30 carbons, plus 2 C7H6O2, that's going to be 4 more carbons. So that gets me all the way to my 34 carbons. It didn't impact my number of hydrogens, it didn't impact my number of carbons. And so this is my balanced chemical reaction. And whenever I look at my exam, or whenever I switch my share, I see that one answer option on there is 14, 6, 2, 15. So that is my correct answer. Okay, question number 2. Which of the following is not an example of a strong acid? And I'm going to be doing this all the while that I'm filling this out. Chem. So I'm filling out my answer key so that I code it correctly. 1, 3, 3, 5. Question number 1, the correct answer is D. Okay. Question number 2, which of the following is not an example of a strong acid? Okay, so you have to know your strong acids. Strong acids are a memorization. Hydrochloric acid is a strong acid. Hydrobromic acid is a strong acid. HClO4 is perchloric acid, and ClO3 is chloric acid. Those two are strong acids. HClO2 is not a strong acid. So answer option D is the correct answer for question number 2. Question number 3. What is the molar mass of MgClO4? Now, to answer this question, you need the periodic table. And so I'm going to open a web browser and I'm going to look at the periodic table because you guys have a periodic table on your exam. And I'm just going to add this all up and keep track of everything that we're doing. Okay. Okay, so my question was about MgClO4. Okay, so Mg is right here. That's 24.305. So I'm going to add 24.305 plus, okay, my formula is ClO42. So that means I've got 2 Cls. So 35.45 plus 35.45 plus oxygen. And it's ClO4 with a 2 outside of the parentheses. So that means that I've got 8 of those. So 8 oxygens would be 128. That gets me to 223.205. So if I look at my answer options, my best option is this guy right here. All right. Okay. Next up is 129.6 grams of AlCl3. Again, we're looking at the periodic table. Al has a mass of 26.982 plus Cl3 is 35.45 plus 35. So I got to count for my 3 AlCl3, or my 3 Cls, which are 35.45. So 129.6 grams of AlCl3 is equal to how many moles? Well, 1 mole of AlCl3 is 133.3. So my best answer there is 0.971. Next up, how many carbon atoms are in 0.67 moles of CO2? Okay, so this question says, or this question is really getting at a conversion from moles of a substance to atoms of that same substance or of that component. So if you have 1 mole of CO2, that means you have 6.02 times 10 to the 23rd molecules of CO2. Each molecule of CO2 has 1 carbon atom. If you have 0.67 moles of CO2, you're going to take this 0.67 and multiply it by 6.02 times 10 to the 23rd. And that gets us 4 times 10 to the 23rd. All right. Next up is, which of the following is an example of a strong base? There's a couple of different options here that are good options. Anything with a hydroxide is going to be a base. H2SO4 doesn't have that OH, so that's off the table. Then we're left with CaOH, FeOH9. Okay, well, FeOH9 is definitely not a strong base, and that implies that iron has a charge of +9, which is pretty unlikely. CaOH, this calcium hydroxide is a strong base, but Ca has a charge of +2. So your formula for that would be OH in parentheses with a 2 subscript after that parentheses. Okay, so that's going to wrap up the video for the first 6 questions. My next video, I'll go over the next few questions. I hope this is helpful.